So we need to find the derivative of our function at this point, and then let's find the slope there. So let's make a note that if we're taking the derivative of sine, the derivative of sine is cosine. And if we're taking the derivative of cosine, the derivative of cosine is minus sine. Now, right now, we can only take the derivative if we have our variable on the inside by itself. If it's to any power or if it has any coefficient, then we're not able to do that. Our variable could be x, it could be theta, it could be t, or whatever. So in this one, our independent variable is theta, so we're taking our derivative with respect to theta. On the right side, we have 3 times the derivative with respect to our variable, theta, of sine theta, minus the derivative of theta. So again, our independent variable, our input is theta, so that's the variable we're using when we take our derivative. So our derivative is 3 times the derivative of sine is cosine. And here's where we often get mixed up. If this were x, if it were the derivative of x with respect to x, then we would more quickly recognize that that derivative is just 1. Or if it's to a power, then it would be bring down the power x to the 1 less power. Well, this is just a variable, just like x is a variable. So when we take the derivative of our variable that's to the first power, we could use the short rule, or we could say bring the 1 down, our variable to the 1 less power. Well, this would be to the 0 power. Anything to the 0 power is 1. In other words, the derivative of our variable to the first power is just 1. So our derivative is just 3 cosine theta minus 1. So we want to find the slope of the tangent line at 0. So when we substitute 0 into our derivative, we get 3 times cosine of 0 minus 1. Notice there's no degree symbol on that, so that's in radians. 0 radians, that's to the right. If we think about our unit circle, the point that's straight to the right is 1, 0. And the x-coordinate tells us the value of cosine. So cosine at 0 radians is 1. So 3 times 1 minus 1. Well, 3 times 1 is 3 minus 1. So we get a slope of 2. So that's our slope. That's our derivative. Let's see. Then there's a question asked about, I was going to ask about velocity. And let's make some notes about velocity. So remember that rate times time equals distance, or rate equals distance divided by time. If we take the change in distance over the change in time, that gives us our rate, or that's also known as the velocity. And this is the average velocity. Average velocity. So you might not be going the same speed the entire time, but if you know how far you've traveled in what amount of time, that distance divided by time will give you, on average, what is the velocity during that time frame. But let's suppose that we have a graph where we have t in this direction and s of t in this direction, where s represents position. So let's suppose that we start out at rest, and then over time, our position is changing. So whatever this graph is, this doesn't necessarily mean we're going up. It just means from a given position, we're at different distances from that starting position. So if we imagine selecting a point and getting the slope there, think about what the units for this slope would be, or what the slope would represent. Remember, slope is rise over run. So the rise would be a change in position. The run, that would be a change in time. Well, a change in position over a change in time is velocity. But that's the velocity at one point. Even though it's the slope of a line, we're looking for the slope at a single point, so that's referred to as instantaneous velocity. So an average velocity, if we know the position at two different points, and we know how much we've changed position, and we know how much we've changed time. But if we're looking at a single time, that takes the derivative to find the slope at a single point. So that's instantaneous, where this slope is average. So if we go back here. So let's jump back over here real quickly. So remember, if we're looking for the slope of a tangent line, that comes from a derivative. So if our position is given by this function, then to get the slope, we need to take the derivative. Well, we said that the slope of that refers to velocity. So that we could call that v of t. So here they give us some initial conditions that we're starting at the top of a building that's 1,311 feet tall. And if we're dropping something, then its initial velocity is 0. So its initial position is at a height of 1,311. Its initial velocity is 0. This is a projectile motion equation for free fall. So if we substitute in our initial velocity and initial position, we would have negative 16t squared plus our initial velocity times time plus our initial position. That would cancel, hence the 16t squared plus 1311. Now so that's s of t. So to get the velocity, that comes from how fast the position is changing. So if we take the derivative of position, we have the negative 16 in the front, bring the 2 down, times t to the 1 less power, and then the derivative of a constant is 0. So our velocity is negative 32 times t. Notice it's dependent on time, because if you drop something, over time it's going to be getting faster and faster and faster. So that's the velocity function. Now, if we need to know the average velocity, remember, average velocity is the change in position over the change in time. So for part B, if we're going from 3 seconds to 4 seconds, our change in time is just 4 minus 3. Our change in position is our position at 4 seconds minus our position at 3 seconds. So we plug 4 into our position function, and then we plug 3 into our position function and see what we get. So if we take 4, square it, times negative 16, plus 1311, at 4 seconds, our position is 1,055. Now let's plug a 3 in. So 3 squared times negative 16 plus 1311. So at 3 seconds, our height is 1,167. From 3 seconds to 4 seconds, that's a 1 second change in time. These distances are in feet, so when we subtract them, we have feet on top, we have seconds on bottom. So 1,055 minus 1,167 over 1. So that's an average velocity of negative 112 feet on top, second on bottom. And that just came from, basically that was the secant line between those 2 points. If we look at a picture, if this was when t is 3 seconds and that's when t is 4 seconds, then what we found was the slope between there, which that gave us the average velocity. Change in position over change in time. Now, part C asks us for the instantaneous velocity. So this function is the velocity at a specific time. So if we want to know the velocity at 3 seconds, we put a 3 in for time. Negative 32 times 3, that's negative 96, and that's feet per second. We need to know the velocity specifically at 4 seconds. Negative 32 times 4, that's negative 128 feet per second. So notice the number is getting bigger, but it's negative. A negative velocity means you're going in the negative direction. So if we consider up to be positive, then we're going down. And this is a larger quantity, which means we're going faster. From 3 seconds to 4 seconds, it's getting faster. All right, part D, what is the time required for it to get to the ground? So if we think about dropping something off the top of the building, to begin with, we said our height was 1311. We don't know the time here, but we know that the height down here is 0. So we want to know when. We want to know the time when we're at the ground. We take our position function, negative 16t squared plus 1311, and we want to know when is that position equal to 0. Several ways we could solve it. We could we could subtract 1311 from both sides. We could divide by negative 16. And then we could take the square root of that. We only want the positive value because we're not going backwards in time. So 1311 over 16. Square root of that. And 9.05 to the 2 decimal places. That's how many seconds it takes for it to hit the ground. Now, if we want to know how fast it's going at the moment it hits the ground, not after it hits the ground, but at the moment it hits the ground, remember that the velocity function is negative 32 times t. So what is the velocity at the instant we get to the ground? That would be after it's been falling for 9.05 seconds. So put 9.05 in. So negative 32 times 9.05. Type that wrong. Negative 32 times 9.05. Negative 289.6. And that's in feet per second. So in a second, that's how fast it would fall. Now that's at that instant. So the instantaneous velocity is that. All right, let's do one more. So find the equation of a parabola that goes through this point and is tangent to that at that point. So let's think about, we have some parabola. We don't know where it's centered, but we have a parabola. It goes through the point 0, 5. So when x is 0, it touches a y value of 5, and it's tangent to this line at that point. So if it's tangent to that line at that point, that means it goes through that point also. So 1, 0, that would be here. So then our parabola is looking more like this. So that gives us 2 points on our parabola. Now let's see what we can get to with that. So if we substitute the point in 0, 5, that means when x is 0, y is 5. So we don't know b or c, but we're substituting a 0 for x, and we know that when x is 0, y is 5. Well, that 0, so that tells us c. So that means so far we have ax to the second plus bx plus 5. Another point that parabola goes through is the point 1, 0, which means when we substitute a 0 for x, a 1 for x, we get that y is 0. So a times 1 to the second plus b times 1 plus 5. So when we put that 1 in, we get 0. So we get 0 on the left, we get a plus b plus 5 on the right. Well, there are 2 variables there, 2 letters, 1 equation. We don't really know what either of those variables are. We just know that, I say variables, those are technically going to be constants in our final answer, but those 2 unknowns, we don't know what they are. We just know that when we add them together, they make -5. Because a plus b plus 5 is 0, or if we move the 5 over, a plus b is -5. So what else do we know? We know that, and our picture may not be right. In fact, it's not right. Because what else are we told? We're told that at this point, at the point 1, 0, our parabola is tangent to this line, 2x minus 2. So 2x minus 2, if we're down to have a slope of 2 and go through that point, will look something like that. So whatever our parabola looks like, we're tangent at that point. So you don't have to exactly know this, but if we were to sketch that, that means our curve or our parabola is going to be parallel to that line at that point, and it's not going to go across it. So our parabola is going to do something like this. So the green line is tangent at that point. We're tangent to the curve there. It touches that point, and so forth. So what do we know? We know that at that point, if that's tangent, that line has a slope of 2. Which means our parabola has to have a slope of 2 at that point. How do we get the slope of our function? We have to take the derivative. So if we take the derivative of ax squared plus bx plus c, then everywhere we have an x, we treat that as a variable. If it's not an x, we treat that as a constant. So a, that's just a coefficient. We leave it alone, and the derivative of x squared is 2x. B is a coefficient, so leave it alone, and the derivative of x is 1. The derivative of a constant is 0. So that means our derivative is 2a times x plus b. Well, what do we know? We know that at the point 1, 0, we have a slope of 2. That means when we substitute a 1 into our derivative, when we replace x with 1, we should have a slope of 2. Let's say that again. At this point, when x is 1, we have a slope of 2. So when we substitute a 1 into our derivative, we should get 2, because remember, a derivative equals the slope. The derivative tells us the slope. So we get that 2a plus b equals 2. If we solve that first one, we already got that a plus b is -5. So we could do substitution, elimination, whatever to solve that system. If we multiply the bottom equation through by -1, we would have a negative there, and a positive there. So if we add these two equations, we would get 2a minus 1a, so a. The b's would cancel, and we would get 7. So that gives us a. Once we know a, we can substitute that in to either of our equations that have a and b. So 2 times a plus b equals 2. So that's 14 plus b is 2. Subtract 14, and that would give us b. So that means our parabola is 7x squared minus 12x and c1. So that's a parabola that has all of those conditions.